Example 8.10. MKZ Airlines currently has A220s on their fleet that need $16 million to maintain per year. Their general manager, Mr. Akan, is wondering whether he can replace these aircraft with more energy efficient models which cost $34 million upfront and $11.75 million per year in maintenance. For simplicity, his maintenance manager, Mr. Oshii, estimates that both existing and new aircraft will be used for the next 10 years. Please use our going discount rate of 3.5% to answer the following questions. So let's just answer them one by one. Is it better to purchase new aircraft or to continue the existing ones? So for the sake of simplicity, I've already laid out all the cash flows here in example 8.10. So this is a 10-year project. For the existing model, there is no cash outflow at time t equals 0, but there are cash outflows for maintenance of 16 for 10 years. For the new, there is a single cash outflow of minus 34 and subsequent cash maintenance outflows of minus 11.75 for 10 years. Now what are we supposed to do? Well, 3.5% is the discount rate. We find out the net present value using the NPV function. So NPV, well, we'll fix it using the dollar sign. So $AB $14. In fact, what I'm going to do is, I apologize, copy that and then comma the values. So all the values plus the time t equals 0th cash flow. So that's the 0th cash flow. And beautiful. So that's the net present value. All we need to do is just control R, because it's going to copy to the right, except the cell that we fixed, it's not going to copy to the right. So these are the net present values. Now to convert these into equivalent annual payments, like we saw in example 8.9, just use the PMT function, PMT rate, and for the number of period, we'll use a count function. So it has to count the number of entries here and determine how many years we got these cash outflows. And the present value is essentially the net present value. The future value is 0 because we've depreciated everything, and the type is 0 as well. So we got a cash outflow existing of 16 per year, which is exactly corresponding with the $16 million cash outflows that we saw in the maintenance expenses. But in the case of the new, because we have a cash outflow at t equals 0, we will not have 16 million, but we'll have or 11.75 million. We'll have 15.84. It'll go up. So that is the first part. Now notice how the per year cost with the new model is lower than the per year cost with the existing model. What it suggests is, since the existing model maintenance is more costly, then even the cost of acquisition of the new model, as it's depreciated over the 10 years, we should go with the new model acquisition. Now in the second part, if the existing aircraft only had useful life of 5 years, how does this comparison change? Well, we have to remove the next 5 cash outflows. And so what happens now is, we can see the net present value has gone down, well, become less negative as compared to this. In other words, new project becomes more expensive, but that's not there is no ground to compare like this, because the lives of these projects are different. So equivalent annual cost with the existing project is still 16 million, because we're spending 16 million per year, and that with the new project is less at $15.84 million. So therefore, even though the life has become shorter, we should still, and the NPV for the new project has become greater negative, we should still go with the acquisition of new aircraft, because its per unit annual cost is lower at 15.84 million. Okay, let's go to the third point. If the discount rate increases, what is the discount rate that makes us indifferent between the two options? Okay, let's see. So first of all, we take a difference of this minus this. So it's negative 0.16. Now these cells, notice, are all linked with the same rate, discount rate. So all we have to do is goal seek this Alt AWG to value 0 by changing the rate. So there we go, and the rate is 4.28%. At the rate of 4.28%, the equivalent payment for both the cash flow streams is now at $16 million. And that makes us indifferent between the two projects. Now, will this hold if we add more cash flow streams? Yes, it does, because notice, even though we added more $16 million cash outflows for the existing project, all we're comparing is the equivalent annual annuity. So even in that case, at a rate of 4.28%, we will be indifferent between the existing and the new project. Now, what happens if the rate goes up further? Let's try at 5%. And we'll see that the existing project will become more profitable. The new project becomes more expensive because the later and bigger cash outflows are now getting discounted at a huge rate. So in fact, at 10%, it is prohibitive to even expect to go with the new project. And that's why we learned three things in this whole example. Number of years is important, the rate is important, and most importantly, NPV does not give us the full picture in terms of comparison of project. And that's example 8.10. Thank you for listening.